welcome to today's KVM Forum. Let's first thank our sponsors who make it possible to have such an event like KVM Forum here, co-located with the Open Source Summit. My name is Bornträger, and I work for IBM as the S390 maintainer in KVM. And I'm going to present the KVM Status Report 2017. So what is KVM Status? As in last year, we have 6 supported architectures. We have, when you count ARM and ARM64 separate, we have ARM, ARM64, MIPS, PowerPC, S390, and of course x86. And as you know, having something in the kernel, in the KVM module, is just not enough to run GAS. You also need user space support. So the most common and most well-maintained user space is probably the QEMU, which supports all architectures that are supported by KVM. It is well-maintained, is very feature-rich, and is basically what is used in most cases. There's also still the native KVM tool, which is less active maintained, but it still supports all architectures except S390, and for specific cases, this might be enough. If you have followed KVM from the last years, you know that Google is also using KVM in their cloud. But Google is not using QEMU or KVM tool. They have their own user space. So we have at least 3 known user spaces driving KVM, which actually shows that having a good kernel interface allows people to do specific things that differ from what people do on other occasions. We have 2 core maintainers, Paolo and Radim, and for all architectures, we have architecture maintainers actively maintaining that architecture. Last year's Keynote basically stopped at 4.8 RC1. So let's have a look at what happened after that. So I first counted the commits, and as you know, statistics lie. So there are several ways of counting how many commits are in KVM, and I decided to go for checking the files that are listed in the maintainers file belonging to KVM. That means I will also count people doing tree-wide changes, and it also means that I do not count changes in memory management like KSM changes. So I hope this will wait out in some way, but it gives you a good impression on what's happening. From 4.8 RC1 till RC4 of today's 4.14 kernel, we have 1,272 non-merge commits. And we have 175 merge commits. Of these, 61 are made by Paolo or Radim, which means these are pull requests where our core maintainers pulled from architecture maintainers. And we have 74 commits, merge commits, made by Linus, usually pulling from Radim, Paolo, or other maintainers. First question, who are the main authors of these commits? On first place, we have Max Sondier, followed by James Hogan and Paolo Boncini. So we have basically ARM, MIPS, x86, and an overall KVM at the top position from the committers. Next question is, writing code is one thing, but how well reviewed is that code? So I have counted the numbers of reviewed bys and arc bys in the commits. We have 417 commits with a reviewed by and 204 commits with an arc by. And who is doing the main work for that? Turns out that there seems to be a pretty good couple. Christopher Dahl seems to be reviewing code from Mark. And in the second place, we have David Hildenbrand doing S390 review, Eric Auger, Paolo Boncini. So thanks to the top reviewers making our code better. Still, with review, bugs can still happen, so you have to fix things. So then I looked into what kind of commits actually fixed bugs. And there's, of course, normal fixes, and there are fixes which explicitly tag a specific commit. You have something called a fixes tag in the commit message, and we have 125 commits out of these 1,272 which have a fixes tag. Then I looked, okay, I have the commit ID of the patch that is being fixed, so I can look who wrote the original patch and who fixed it. And what I found interesting is that the fixer, in most cases, is a different person than the author of the original patch. You can say this is good or bad. I think this is good because it shows that we have more than one person looking at the same code, many people maintaining the same code. So who are our top repairmen? We have Paul Macaris, Radim, and Paolo Bonzini. Thanks as well for fixing our bugs. Okay, now, next question might be, what are the releases? Do we have a flat rate of commits or not? And it turns out that we have short releases, or small releases, and large releases. So you can see 4.8 was really a large release. We had some kind of S390 nested virtualization in it. 4.12 was a large release. 4.10 was pretty small. And knowing that 4.14 is going to be a long-term stable kernel, KVM shines by not pushing any kind of crap into the next stable release. We have been just pushing the best patches that we had, obviously. I also checked, okay, how many patches did we add after RC1, and how many patches flew in during the merge window? And it turns out we have about a rate of 15% of patches coming in after RC1. So I think this is also a pretty good sign that KVM is being a good citizen by pushing the features in the merge window and let's just adding fixes after RC1. Next question. Do we have some kind of distribution for architectures? It turns out, yes, x86 and ARM are the most common architectures for commits. MIPS is interesting because it has some kind of on-off pattern, basically kernel releases with many patches and releases with almost no patches. S390 and Power are basically flat on some kind of lower ratio. But overall, all architectures are represented in a pretty decent way. There is no totally big outlier or something like that. Then, of course, who wrote all these patches? And this is actually a good message because we have, when you look just at the code, we have more than 15 companies contributing to KVM. We have, of course, Red Hat as the overall maintainer, also doing x86. We have IBM, of course, focusing on Power and IBM Z. We have ARM Linaro working on ARM, of course. We have Google working on x86, nested virtualization. We had Imagination working on MIPS. Then there are other companies like Tencent Cloud, SUSE, Oracle, Virtuoso, KVM, Amazon, Intel, AMD, and others actively providing changes to KVM. Another good thing is that we have more companies. When you just follow KVM Forum, if you look at the list of presentations, and if you also follow the mailing list, we have more companies than just these existing companies actively participating in our community. So our community is growing. And I think this is really a good message. So I will just welcome any new company that is working on KVM. It's good to have you here. So what are the highlights when you look in the common code that is not architecture specific? Last year we had several changes in plumbing code or management tooling, performance tooling around KVM. We have improved the KVM stats to now hold 64-bit values. The KVM stat tool itself got a lot of improvements. You can now select specific guests. You can do other filtering things. You now have events when guests are created and stopped, so your management application can do specific things about that. A lot of cleanups happened. So Radim, for example, did some kind of rework for the vCPU requests. We have now proper annotations for all RCU code in KVM, and we moved KVM config from x86 back to all architectures. And of course, there are performance improvements that will help all architectures in common code. So, for example, we have now an alternative way to kick guests out of of KVM into user space. Instead of using signals, we have a different way that improves performance by not basically blocking on a specific lock on big NUMA systems. And we also improved the heuristics for spin lock preemption. What are the highlights on S390? Of course, the big thing for S390 or IBM Z is the new Z14. So we basically support all the new hardware things like new SIMD instructions, new execute, all the new crypto instructions that we have, SHA-3, Galois counter mode, you name it, guarded storage support. You can just read that list, or if you're interested in some, just ask the specific maintainers. We have most people here. We also do support machine check forwarding now, and we did some more optimizations in our core code. Power, basically the same story. The main thing is really Power 9. So the IBM is focusing to support the latest machines. So with Power 9, we now have Radix tree support for the page tables. The in-kernel interrupt controller can now use the XIVE engine to speed up things, and you can also have guests with 2, 4, or 8 threads in Power 9 mode in the guest. Power also supports IRQ forwarding now, so when you have a real device attached to a guest, the IRQs can be forwarded. You have storage keys, resizable hash page tables, improved MMO emulation, machine check handling. And what is also interesting is Power also has hard polling support now, which is actually a common code feature, which was not enabled in Power code. And they had to do something special, but they basically have the same feature set here as well. Looking at x86, when reading all the commits, the main focus clearly was on nested virtualization. You can now run Hyper-V under KVM, which is really a nice achievement, because this is not something you usually do when you develop your nested thing, because you would just test KVM under KVM. Now we can also run Hyper-V. Lots of fixes and enhancements. x86 now also supports additional guest features like AVX 512, or we can now have 5-level page tables in the guest and the host. Lots of emulations, improved page table hashing, other things. And the PTP support for the timer, or the AMD's exitless interrupt injection. So the biggest change for ARM is probably the work on the interrupt controller. That seems to be the most important thing for ARM right now. Lots of improvements here. We have migration support for the version 3. There's also a way to run the IRQ chip in user space, which is necessary for specific ARM boards where you cannot use the kernel one. World split optimization, lots of other things. Then, of course, ARM now also supports the vCPU requests, and it supports memory poisoning on S-error. What are the highlights from MIPS? As you might know, MIPS was basically doing a trap and emulate implementation of KVM. There are some improvements here as well, but the main important change is probably that MIPS now supports the hardware virtualization of these chips that are listed here, and basically it supports MIPS 32, 64, it supports the FPU, the SIMD, the hardware page table walker, you name it. Basically, you have a proper support for hardware virtualization, which is also quite nice. And we now had common code KVM, we had the architecture code, but this is not just the core KVM that we should focus on. When you look at other components in the kernel that are related to KVM, there is VFRO. You can now have virtual GPUs. On S390, you can pass through channel devices. We are also working on the crypto cards on S390. Then there's another project, KVM unit test. Thanks to the work of Thomas Huth from Red Hat, we now have S390 support as well. And thanks, David Hildman as well. And you can also do parallel execution of test cases with the -J option, which is also nice, especially when you look into CI environments where you want to have tests be running as fast as possible. In Wörter O, we have seen Wörter O crypto in the last year, basically coming up and being established. And in KSM, there are discussions regarding new hash algorithms to improve performance. And there's also special handling for zero-page detection. And in addition to that, there are also many vendors I know of which do support KVM now in their product. Backup vendors, failover vendors. So I think KVM is still a very lively community, and I wish you now a very nice KVM forum. Most of you have been here yesterday as well. So ending my talk on time, and now comes Christopher Dell with his next talk, and thank you and welcome.